Question number 25. Choose the transfer function that best fits the output response to a unit step input change. So basically we have a transfer function and there's an input and output here, and so there's a unit step change here, the input, and the response curve is shown here, and there are 4 options given. So we have to see, we have to find out which particular option here matches with the response shown in this particular diagram here. In general, let's say a transfer function can be represented as we have zeros, and then we have the time delay term here divided by poles. Okay. So in this particular response we can see there is a time delay here, so this term has to be there in the transfer function. So if we look into option A and option B and option D, all of them have this time delay term. So option C does not have, so we can straightway delete this one. So this could not be an option, a probable option. Now let's look into option B here. Option B has 2 first order terms in series. That will of course lead to a monotonic response. That means no overshoot here can be expected, which of course we already have, which is shown over here. So option B cannot be a possible option, so we just reject this one. Now in between, so we have 2 contenders here. There's option A and option D. What's the difference between the two? Only difference is that here this in the zeros, now this is the second order 0 here in option D. This is highly unlikely, and normally we do not encounter in practical systems, and even if we do, this will not lead to a smooth attainment of steady state. That will be quite oscillatory and unstable. So considering the options A and option D, option A seems to be the best contender for the correct option, because it has a second order term over here that will lead to this overshoot. It shows the time delay, which is right here, and of course with -1 over alpha, that will lead to a smooth transition to a steady state. So considering all these options, option A is the best answer or is the correct option.